this video, we'll be looking at angles in circles and in particular the fact that angles in the same segment are equal. So when we talk about angles in the same segment being equal or angles subtended by the same arc being equal, we mean that we've got an arc, say here highlighted in red, which is subtending an angle of theta over here, and the angle subtended by the same arc at the circumference is also theta, and therefore all the angles which originate from this arc and are subtended on the circumference of this circle will have the same size of theta. Now it's good to bear in mind that if we're looking from below, then the arc is the one highlighted here in yellow, and the two angles subtended by this arc are shown here, highlighted, here and here. And if someone is looking from above, then the arc of interest is the one highlighted in green here, and the two angles subtended by this arc are here and here. So the two angles in yellow are of the same size, and similarly the two angles highlighted in green are of the same size. Now let's take a quick look at a simple example. We've got a situation here and we need to find the angles x and y, and we need to give reasons to justify our answers. We notice that all three angles here are subtended by the same arc, which I'm going to highlight in red, and therefore we can easily conclude that both x and y will be 33 degrees. The reason is that angles subtended by the same arc are equal, or simply that angles in the same segment are equal. In the first example here, we need to find x and y. We need to provide reasons. So starting with x, we notice that the x and the 40 are angles in the same segment, so I can easily conclude that x is equal to 40. The reason is that angles in the same segment are equal. And similarly, if I look at this situation from above, I see that the arc which is subtending the 50 is also the same arc which is subtending the y, and therefore we can also conclude that y is equal to 50 for exactly the same reason. Angles in the same segment are equal. In the second example, we need to find angle y here and angle x. So we can start by observing from above and noticing that this arc here is subtending an angle of 75 at the circumference, which should be equal to x. So x is 75, and the reason is angles in the same segment are equal. And then to proceed in finding y, I will actually start by labeling this angle here theta. We have already found x to be 75 degrees. It's a good idea to annotate my diagram with all the information I have found. So theta is 180 minus 75 plus 43. I'm using the fact that the angles in a triangle are adding up to 180 degrees. This gives an answer of 62 degrees. I need to state the reason that angles in a triangle add up to 180 degrees. Now, once we found theta to be 62 degrees, it's obvious that y must be 180 minus 62. The reason is that we've got angles on a line, and these should be adding up to 180 degrees. So we get that y is 118 degrees, and the reason is that angles on a line add up to 180 degrees. Now, to prove that the angles in the same segment are equal, I will start by considering this situation here. I will call angle ACB to be theta, and the objective is to conclude that angle ADB is also theta. Now to do that, I will start by considering the center of the circle O, and I will join A with O and O with B. Now I will call, we said, ACB to be theta, and then we know that angle AOB should be 2 theta, should be twice the size of angle ACB. The reason is that the angle at the center is twice the angle at the circumference. And then I can repeat exactly the same idea. I've got the angle at the center, so this should be twice the angle at the circumference. So ADB should also be theta. The reason is, again, angle at the center is twice the angle at the circumference. We need to write everything down here to justify the conclusions because we are constructing a proof. So the reason is, again, angle at the center is twice the angle at the circumference, and therefore we conclude that the two angles in the same segment are of the same size, and therefore we have that the ACB is equal to the ADB. Angles in the same segment are equal. Thanks for watching. If you found this video useful, please like it and subscribe to our channel. You can also leave a comment below to tell us what you think.